formulas, so what the difference between them is, and also how we can write one given the other. Okay, so the empirical formula is the lowest whole number ratio of atoms in a compound. Okay, so keep in mind that these empirical and molecular formulas have to do with just your molecular substances only. So molecular, remember, we can also call them covalent. Okay, so these are for molecules where they are covalently bonded, which we'll talk about, with nonmetals only. Okay, so this has nothing to do with ionic compounds. So the empirical formula first is the lowest whole number ratio of atoms in a compound. So for example, C6H6 would have an imperial formula of CH. Okay, so each has a subscript of 6, so the lowest whole number ratio of them would turn its empirical formula to be CH. C6H12O6 would have an empirical formula of CH2O. Empirical formula can also be the same as a molecular formula. Okay, so if it can't be simplified, you can't have it already is in its lowest whole number ratio of atoms, like water. Like we can't simplify that anymore. Okay, so water, that's its molecular formula. Water always has two hydrogens bonded to an oxygen atom. So that's the molecular formula, but it could also be its empirical formula as well, okay? Because it is its lowest whole number ratio already. So a molecular formula is going to represent the true formula of a substance, so what it actually is. So the specific amount of atoms that are in that molecule or that make up that molecule. So unlike ionic formulas that need to be simplified, a molecular compound such as dinitrogen tetroxide or N2O4 would not be simplified because that is the molecular formula. So for example, we can look at carbon dioxide. Okay, so carbon dioxide, one molecule would look like what I drew before. So I drew the Lewis structure of that. Okay, so every carbon dioxide molecule is going to have a carbon with two oxygens attached, covalently bonded to it. So this is going to be different than what your ionic compounds are because they're not bonding in the same exact way. Okay, so the molecular formula is just representing the true formula of the substance, exactly how many atoms that are within that structure. Okay, so we're going to first go over how to determine an empirical formula from a molecular formula, or determining the simplified formula given its true formula. Okay, so the first step is to find the largest common multiple of all the subscripts that are present. And then we want to divide each subscript by that multiple to create this empirical formula. Okay, so I'll do these two examples. So we have C6H9O3. So the largest common multiple between 6, 9, and 3 is going to be 3, right? 3 can go into 3, 3 can go into 6, and 3 can go into 9. So our largest common multiple would be 3. So we want to divide this largest common multiple by all of the subscripts in the molecular formula to simplify it. So our empirical formula now would be, we would take the carbons, there's 6 of them. We divide the 6 by 3. Now we have 2. For our hydrogens, our molecular formula has 9, but if we simplify that by dividing by our 3, now we have 3. And then our oxygens, there's 3 of them in the molecular formula. Divide that subscript by 3, so there's only just going to be 1 of them. So the empirical formula of C6H9O3, the simplified version, would be C2H3O. Okay, based off of that largest common multiple of the subscripts being a 3. Okay, so now if we have C6H14, okay, so what's the largest common multiple that would go into there? Well, the largest common multiple is going to be a 2. Okay, so a 2 can go into 6, a 2 can go into, or can be divided by 14 as well. So if we want to rewrite this simplified empirical formula, we take the subscript of the carbon, which is a 6, divided by our largest common multiple. So 6 divided by 2 give us C3. And then for our hydrogens, we have 14 in the true formula. Divide that by the largest common multiple of 2. 14 divided by 2 gives us 7. Okay, so we took the true formulas, okay, exactly what truly is there, and we created this empirical, or like a simplified version, okay, just a simplified version of it. Okay, so what if we want to determine what the molecular or the true formula is given a empirical or a simplified formula? So this is going to take a few more steps, but we can read this through quickly. So consider the empirical formula CH2. This empirical formula can yield many molecule formulas, including CH2, C2H4, C3H6, and C4H8. Okay, so it's just showing that these are different types of molecules you can have, and these are the molecular formulas or the true formulas. So all of those they share the same, or they share similar largest common multiples, where that when they are simplified as much as they could, their empirical formulas would end up being the same, CH2. Okay, so it becomes important to incorporate the molar mass, okay, or molecular mass, the gram formula mass, so that we're able to figure out exactly which molecular formula that it pertains to. Okay, so the first step is to determine the gram formula mass of the empirical formula. Then you want to divide the gram formula mass of the molecular formula by the gram formula mass of the empirical to find this common multiple. And then the last step would be to multiply, so do the reverse. We're going to multiply each subscript of that empirical or simplified formula by that common multiple to determine what the true formula or molecular formula is. Okay, so let's just go through step by step. So determine the molecular formula of a substance that has the molecular mass of 84.9 grams per mole, and its empirical formula is CH2. Okay, so this 84.9 that they're giving us is the gram formula mass of the molecular. Okay, that's the true formula. And then they just give us a simplified formula is CH2. Okay, so we want to figure out first what the gram formula mass of the CH2 is. So we have hydrogens and we have carbons. We have 2 hydrogens, each with a atomic mass of 1. And then we have 1 carbon, each has a atomic mass of 12. Okay, so by adding all of this together, we get that the mass of our CH2, that empirical formula, is 14 grams per mole. Second step is we want to divide the mass of the GFM of the molecular formula by the mass of the empirical. Okay, so we're going to put GFM molecular, the bigger number, over the GFM of the empirical, okay, because we want to get like a larger whole number. We don't want any decimals. Okay, so we're going to take that 84.9 grams per mole that they gave us in the question, and then we're going to plug in that empirical formula mass that we found in the first step, 14. So we'll plug this into our calculator and we get a number 6.06. Okay, you're just going to want to round it to the nearest whole number. So we can say that that's about 6. Okay, we want our common multiple to be a whole number, like 6. So then the last step would be to multiply each of the subscripts in the empirical formula by that common multiple. So if we have CH2, we want to multiply those subscripts by a 6. Okay, we're not multiplying any coefficients. We're just focusing on multiplying the subscripts, the little numbers. So if there's 1 carbon in CH2, we multiply that 1 by 6. So we get C6. And then that hydrogen, there's 2 in the empirical formula. We multiply that 2 by the 6 to get 12. So that turns into H12. Okay, so this would be our true molecular formula. Okay, given the molecular formula's mass to begin with, and then also the empirical formula. Okay, so we're able to figure it out that way.